for, what are we doing? Quiz 2 for Math 251. We're given this weird graph. Apparently it's a graph of f, and asked to evaluate a bunch of limits or state that they are undefined. First one says, what is the limit of this function f of x as x approaches 2 from the positive side? Here's where x is equal to, so it's kind of asking what's the y value, but not at 2, but when we're just slightly bigger than 2. So now we're talking about up here. The height is approaching 5 as my x value is approaching 2 from the left. You're thinking about the little guy standing up here. So what that tells me is this limit, whoops, is equal to 5. I don't know what kind of work you could show, so I won't show any. What about the limit as x approaches -4 from the positive side? Here's -4. This is the positive side, so the little guy is standing down here. The height down here is -2, therefore my answer is -2. Maybe I'll draw it in there. Maybe that's helpful for somebody. This one would be up here. I doubt that's helpful for anybody, but whatever. The limit as x approaches -4. It doesn't tell me which side. Okay, if I come from the right-hand side, I have a height of -2. If I come from the left-hand side, I have a height of 3. What that tells me is this is undefined. What about the limit as x approaches -1? It doesn't tell me what side I'm approaching from. Well, let's see. Here's -1. When I approach from the right, I'm getting close to a height of 4. Sorry, this is the right. When I approach from the right, I'm getting close to a height of 4. When I approach from the left, I get close to a height of 4. Either way, the height is getting close to 4. Either way, my answer is 4. And then finally, the limit as x approaches 4. Again, it doesn't tell me which side, so I have to consider both sides. When I come from the right, my height approaches 2. Can't tell left and right, apparently. When I come from the left, my height approaches 2. When I come from the right, my height also approaches 2. Because 2 is the same as 2, my answer is 2. That's it. Call that good. Moving on. Evaluate a bunch of limits. All right, this first type, sort of the trick for it is I got a polynomial. You try changing all the x's into 3's and you'll get 0 divided by 0. What that means is x minus 3 must be a factor of the top and the bottom somehow. All right, I already have an x minus 3 in the bottom. That's the good news. There must be an x minus 3 in the top, but I can't see it. Maybe you can see it, I don't know. But there is an x minus 3 up there. If you want me to show you where, what we'll have to do is factor 2x squared minus 3x minus 9. Lots of different ways to factor this. There's really a one-step process, kind of a guess and check method. But I usually teach people a different method. I'll talk through it here in case it's helpful for you. The method that I use, it's a 3-step process. I don't really use this method, but the method that I teach is a 3-step process. The first step is you got to find two numbers that add to -3 and multiply to -18, the product of 2 and -9. Multiply to -18, add to -3. I think -6 and +3 will do that. Those are not your answers. You do not have the factored form. You just have the new coefficients on your linear term. What I'm saying is those two numbers, the two numbers that multiply to -18 and add to -3, which were -6 and +3, are what I replaced -3x with. Note that -6x plus 3x is the same as -6x plus 3x is the same as -3x. This isn't factored. That's okay. I've rewritten it in a form that will be easier to factor. Now that I have 4 terms here, I have a method that'll work for factoring, namely factoring by grouping. You look at your first group here, the first 2 terms. Their greatest common factor is 2x. If I pull out a 2x from these first 2 terms, what I'd be left with is x minus 3. X minus 3 becomes my target. It's what I want to be left with when I factor something out from my second group here. I have to be left with x minus 3, I better factor out a +3. Note that if I factor out +3 from these 2 terms here, I'm left with x minus 3. What I now have are 2 terms. Here's one of them, all this stuff. Here's the other one, all this stuff. Both of my terms have an x minus 3 in them. So I can factor out that x minus 3, and what's left behind is 2x plus 3. A lot of people can go straight from this all the way down to this. There's a guess and check method that'll get you there. If you can do that, that's fine. I don't care. Do it however the hell you want. I just want to talk through another method so that you have another way of doing these. Anyways, all that just to say that 2x squared minus 3x minus 9 is the same as x minus 3 times 2x plus 3. This is good because I can cancel out these x minus 3's. Be careful. This thing is not equal to 2x plus 3. However, the limit as x approaches 3 of this thing is equal to the limit as x approaches 3 of what I'd have if I canceled out the x minus 3's, namely 2x plus 3. The nice thing about this limit is I can evaluate it. I can figure out what it's equal to by changing all the x's into 3's. Change all the x's into 3's. 2 times 3 is 6, plus 3 sounds like 9. The answer to this limit is 9. What about this one? Different looking limit, same problem. If all my h's get changed into zeros, I get 1/3 minus 1/3 divided by 0. 1/3 minus 1/3 is 0. I get 0 over 0. What that's saying is that there must be a way to cancel out this h down here. And there is. The trick for doing it is you first want to make this one fraction divided by one other fraction. I have two fractions up top, which is kind of problematic. I want to change those into one fraction. Instead of having 1/3 and 1 over 3 plus h, I just want a single fraction up on the top. Changing the bottom into a fraction, that's easy. Just write it as h over 1. But changing the top into a single fraction is hard. The way you put together two fractions, well, you can only put them together if they have the same denominator. The least common denominator in this case is 3 times 3 plus h. In order to get that least common denominator, I'll have to multiply this fraction by 3 plus h over 3 plus h, and this fraction by 3 over 3. What that gives me is the limit as h approaches 0 of, see, I'd have 3 plus h in the numerator over here, minus 3 in the numerator over here, and because I have a common denominator of 3 plus h times 3, I can put these all together and only write the denominator one time. That's the top part. That whole thing gets divided by h over 1. Fraction divided by a fraction is something I can deal with. The way you divide fractions is kind of like multiplying fractions, except you multiply by the reciprocal of the denominator. You take this h divided by 1, and you flip it upside down and make it a multiplication problem. While I'm doing that, you might want to notice that 3 plus h minus 3 is just h, right? 3 and negative 3 cancel out. So the top here becomes h divided by 3 plus h times 3. And the bottom, I flip it upside down, so instead of h over 1, I get 1 over h. Look, those h's will cancel out. This is not equal to what you'd have when you cancel out the h's. However, if you write limit as h approaches 0, then it is equal. So this is equal to the limit as h approaches 0 of 1 over, I'm going to write 3 times 3 plus h instead of 3 plus h times 3. This just is prettier, if you ask me. This is a limit I can evaluate. I can change all my h's into zeros and not be worried about dividing by 0. Change all my h's into zeros and I'll get 1 over 3 times 3 plus 0. 1 over 3 times 3. 1 over 3 times 3 is the same as 1 over 9, which is the limit and the answer to this question. Moving on, last one. The old square root ones. The trick for dealing with square roots. Anytime you see a square root in this class, and we're trying to evaluate, okay, let me start over. Start by trying to change all your x's into 9. Damn, it doesn't work. This is 0 and this is 0. It's too bad. I'm going to have to do some sort of algebra to cancel out this x minus 9. The trick for canceling out this x minus 9 is by multiplying the numerator and the denominator by what's called the conjugate of the numerator. Sounds worse than it is. All I'm saying is let's take the top here and the bottom here and multiply them both by, maybe I need another color, the square root of x, like I have here, but instead of minus 3, let's do plus 3. Why? Because you've memorized that anytime you see square roots, you multiply the top and the bottom by the conjugate of the top. This is the conjugate of the top. Might be hard to see how this is going to work out, but it will. An x minus 9, to cancel this out, will magically pop out of the top. Okay, maybe not magically, but it'll pop out of the top. The square root of x times the square root of x is just x. The square root of x times 3 is 3 times the square root of x. The square root of x times negative 3 is negative 3 times the square root of x. Those two things cancel out. 3 root x and negative 3 root x. Negative 3 times positive 3 is negative 9. If you FOIL out the top, you just get x minus 9. Don't bother FOILing out the bottom because we want to cancel out this x minus 9. So we don't want to hide it by FOILing it back out. We want to leave it like this. I can now cancel out those x minus 9s. Probably getting sick of me saying it by now, but I'm going to say it one more time. You can't just cancel out the x minus 9s except for the fact that I wrote limit right here. This is what allows me to cancel out these x minus 9s. When I cancel them out, I get this, which is a limit I can evaluate. I can change all the x's into 9s. And get 1/6. That's the answer to this question. And I guess that's the end of the quiz.